On this RAM 1500 with the 3.6 Pentastar, P0351 points to the ignition coil 1 primary control side. In plain terms, the PCM may not be seeing the expected current behavior on the coil 1 signal circuit. The truck may turn the MIL on, and depending on how the fault is acting, it can run rough, misfire, or have a no-start type complaint. Broadly, possible fault areas can include the fused relay output feed, the coil 1 control circuit, the coil itself, related connector problems, and in some cases the PCM-driver. Start with the basic system checks, then prove the code is active before getting deep into circuit testing. First, scan all modules and record the DTCs and the environmental data. Save the scan report and the related recorded data so you know what the vehicle was doing when the fault set. Clear the codes, turn the ignition off for a minimum of 0 seconds, then turn the ignition back on. Reproduce the operating conditions that set the code and read codes again. If P0351 does not return, treat it as an intermittent condition and do not force a conclusion. If it does return, keep going. The monitor for this fault runs continuously with the ignition on. The set logic is that the PCM detects the ignition coil 1 signal circuit current at less than or equal to 0 amps for at least 2 seconds. That tells you this is an electrical circuit diagnosis first. Prove power supply, prove control circuit behavior, then separate coil, plug, wiring, connector, and PCM driver possibilities. Before testing the coil circuit, look back at the recorded codes. If any ASD-related codes are present, diagnose those first. The coil feed depends on that side of the system, so chasing coil 1 before handling an ASD fault can send you in the wrong direction. If there are no ASD-related codes, move on to the feed circuit load test. Next, isolate the 12-volt supply circuit by disconnecting the component harness connector. Load test the relay output feed at the component connector using a good ground at the battery or chassis. Make sure the circuit is actually powered while you test it. If the feed depends on ignition or a relay state, the ignition has to be on and the relay has to be energized. A good circuit should light the load test bulb bright. A load test matters here because a circuit can show voltage and still not carry the current the coil needs. A 3156 bulb has approximately 6.0 ohms of resistance and draws approximately 2.0 amps of current. A high impedance test light that draws less than 0.1 amps is not enough for this load test. The tool should draw more than approximately 0.75 amps. As a working example, 2.0 ohms of resistance in the circuit being tested can make the load test show 25% less than when compared to battery voltage because that creates total circuit resistance of 8.0 ohms. If the bulb is not illuminated and bright, repair the 12-volt circuit for an open or high resistance. If the fuse is open, check that circuit for a short to ground. Then verify the repair and confirm the code stays gone. If the feed circuit passes the load test, check the coil 1 control circuit operation. Use a 12-volt test light connected to a 12-volt source. Probe the coil 1 control circuit at the ignition coil harness connector and crank the engine for 5.0 seconds while watching the light. Stay clear of the fan, pulleys, belts, and moving parts while the engine is cranking or running. The light pattern determines the next direction. Brightly blinking sends you to the spark plug and coil side. On constantly sends you toward a short to ground check. Off constantly sends you toward an open or high resistance check. When the control test light is brightly blinking, shut the ignition off and inspect the spark plug for cracks, carbon tracking, foreign material, gap size out of specifications, or a loose or broken electrode. If any of those conditions are present, replace the spark plug. If carbon tracking is found on the plug, inspect the ignition coil boot for damage and replace the boot if needed. If none of those plug conditions are present, replace the ignition coil and spark plug. After that, verify the repair and confirm the code stays gone. If the test light is on constantly while cranking, isolate the coil 1 control circuit and check it for a short to ground. The ignition must be off for this continuity to ground test. Disconnect the control unit and every connector that contains the circuit being tested, then use the wiring path to isolate the circuit. With the negative meter lead on a known good ground, probe the control circuit at the component connector with the positive lead. There should be no continuity between ground and that circuit. If continuity is present, repair the control circuit for a short to ground, using inline connectors to help narrow down the short location. Then verify the repair and confirm the code stays gone. If there is no continuity to ground, continue to the coil driver isolation step. If the test light is off constantly while cranking, isolate the coil 1 control circuit and check it for an open or high resistance. The ignition must be off for this continuity test. Disconnect the control unit and the component connector that contain the circuit. Before measuring the circuit, measure the resistance between the 2 meter leads so you know what the meter and leads are adding. Measure between the control circuit at the component connector and the same circuit at the GPEC adapter. Do not probe the PCM harness connectors directly because that can damage the terminals and create a poor terminal-to-pin connection. Use the GPEC diagnostic adapter when testing at the PCM side. Also remember the GPEC diagnostic adapter can add up to 1.5 ohms of resistance to the circuit. If the circuit resistance is below 3.0 ohms, continue to the coil driver isolation step. If it is not below 3.0 ohms, repair the circuit for an open or high resistance, then verify the repair and confirm the code stays gone. Before condemning the PCM, determine whether the ignition coil may have caused the driver problem. An internally shorted or damaged secondary coil circuit may be the reason the PCM coil driver failed, so do not replace the PCM until the coil has been checked this way. Remove the ignition coil controlled by the driver that's set P0351 and install that coil in another cylinder location that did not have a fault set against it. Turn the ignition on, clear the codes, then start and run the engine for up to 1 minute. If the engine will not start, crank the engine 3 times for 10 seconds. Read the codes again. If a correlating fault sets for the new coil location, replace the ignition coil and replace and program the PCM. Then verify the repair and confirm the code stays gone. If a correlating fault does not set for the new coil location, continue with connection checks. If the coil does not carry the fault to the new location, inspect the related PCM, harness, inline, and component connections. Perform any applicable service bulletins. Disconnect the PCM connectors, any related inline connectors, and the related component connectors. Look for connector installation problems, damaged locks, corrosion, signs of water intrusion, whether seal damage, bent terminals, overheated or discolored terminals from a poor connection, push-back terminals, spread terminals, and poor terminal tension. Repair any conditions found. Then reconnect every connector fully and make sure the locks are engaged. Clear the codes, operate the vehicle under the conditions that set the fault, and read codes again. If P0351 returns after those checks, replace and program the PCM. If it does not return, the wiring or poor connection problem has been repaired. Finish by verifying the repair and confirming the code stays gone. The key with P0351 is to stay in order. Confirm the code, rule out ASD-related problems, load test the coil feed, read the coil control pattern, then isolate whether the fault is plug, coil, wiring, connection, or PCM-driver related. Do not jump to a PCM until the coil and circuit checks have earned that call. For more diagnostic training, visit stepdiagnostics.com.